Hi guys, so today we have another GTR related video. This one is looking at the instrument cluster. This is from a 2009 GTR, and there's a common problem with these, especially the older ones, that the backlighting fails on them. So the backlighting is the lights that illuminate the numbers around these dials. So on the speedo, the tacho, the illumination of the two dials here, the temperature gauge, water temperature and fuel gauge. Also the backlight on the shift indicator, which is here. There's an LCD display there that displays the shift indicator. And all of these are susceptible to failure. What tends to happen, which is odd, I'm not sure why this happens, but they tend to fail from the right-hand side over to the left-hand side. So people with the issue, this one included, the temperature gauge is the first one to fail, and then the fuel gauge and the shift indicator, and then it moves over to the tacho and the speedo. So it kind of comes across, and I've seen some of them, some pictures of these where they're all out. You know, every one is out. They've all failed, and they do that progressively over time. So this one, the issue is it's only just started on the temperature gauge here. So occasionally this will flicker on and off, and it's the start of the problem. So I thought I would get this dealt with now, and it involves replacing the surface mount LEDs that are in this unit. So we need to take it apart and replace all those. So I've not opened it up yet, but looking online, the LEDs are of type PLCC4, which means they are 4-pin devices. And these ones, I believe, we can test that when we open it up, but I believe they're common cathode, which means that one of the pins is common cathode or ground, and the other three are all anodes or plus volts, probably 2 or 3 volts when they're in circuit. But again, we can test that when we have it apart. So what I'm hoping to do in this video is to show you how to open up this cluster, identify and remove the backlight LEDs and replace them with new ones. Now, what you'll probably want to do when this is apart and when it's on the bench, when you're doing this, is power it up, because you want to see which LEDs we're talking about, and also as you replace them, you can put power to the unit and just make sure that they've been soldered on correctly, the right way around, and they're working properly. So what I'm going to do is power this up from a 12-volt source. Now we can do this. This is done by applying 12 volts to some pins at the back. So if I turn this round, this is what the back looks like, and this is the main socket here which connects to the car. So attaching power onto various pins here is going to power this unit up, and we'll be able to test that on the bench. So the power needed on these pins, I'll put a diagram up on the screen of what this looks like. But we have pin 1, which is 12 volts. Now when it's in the car, this is the permanent 12 volts from the car battery. This is always powered. Pin 2 is the ignition. So that's the 12 volt when the ignition's on. Then we have pins 3, 4 and 5, which are all ground. It doesn't matter which one you connect up to. So putting power and ground on those pins, that will power up this unit. Now, with this being out of the car, the brightness will set to a default setting, which is quite low. It does light them up, so you can see it, but if you want to increase that brightness, then we can mimic the action of pushing the brightness increase button in the car. And we can do that just by connecting 2 pins together on here. So that's pins 6 and 24. So if they're just briefly connected together, what will happen is it'll just increase the brightness until it reaches maximum brightness. But I can show you that as well. So I'll get these wires attached and we'll try that out. I'm using some of these leads here. These are just single pin leads. They're mainly used for the 0.1 pitch circuit boards or Vera boards or the bread boards. They're just useful little connectors to have. So you can get these in female to female or male to male, or like this, male to female. And they're just useful for connecting onto plugs like this, because they'll just slip over the pins and then you can use the other side for the connection. So pin 1, the numbers run from 1 to 20, and then at the bottom row it's 21 to 40. So pin 1 is the battery connection, 12 volts. Pin 2 is the ignition switch, 12 volts, so both of those will be on 12 volts. And then pins 3, 4 or 5 are all ground, so you can just put it onto one of those. So that's all you need to power the thing up. Like I said, if you want to increase the illumination, which I would recommend, then I'm going to get another 2 leads here and put those on pin 6 and 23. 21, 22, 23, sorry, pin 24 it is, not 23. 21, 22, 23, 24. Okay, 6 and 24. That's those 2. Pins 1 and 2. It's going to be plus 12 volts. Pin 3, 4 or 5 is ground. And then these are our 2 other ones, 6 and 24 for the illumination. So let's power this up. So that's it powered up. You can see that the illumination is quite dim. Just turn the light off there, but it is still quite dark. So if we connect these 2 pins together, this will increase the brightness. And there's maximum brightness. So that just helps you see the illumination there. So you can see the white rings lit up, the number rings, and the backlight on the fuel gauge and the backlight on the temperature gauge. Also the backlight on the shift indicator. It's not lit up when it's not in the car. That's it's not active, but this is where you would have the numbers for reverse or drive or whatever you're in. Obviously, the fuel and temperature is misreading because it's not connected to anything as well. But as far as I can tell, all of the LEDs that need replacing are just the white ones, just the backlight illumination lights. So the lights that light up this display here, the amber ones, the red LEDs on the needles, and the red and amber LEDs on all of these warning lights, they're all fine. You don't need to replace those. It's just the white ones, and I believe they were just poor quality LEDs that were fitted, so they didn't stand the test of time. So what we'll do is we will open this up. It involves taking the front cover off. It involves taking these rings off, so these clip in, these pull off the display, and then we need to pull the needles off as well. And once all that's removed, this facia, the bit with the actual numbers written on it, that will come off and reveal the circuit board with the LEDs. So in order to get this front plastic cover off, we need to release these clips here. There's 4 clips, there's 2 there, and then there's 2 more under this felt. So need to take off this felt from the side. It's just self-adhesive. I think this stops it rubbing on the dashboard when it's back in there, so you will need to put this back on. If the sticky's not sticky anymore, then you can always just put a bit of glue or double-sided tape on the back of that. And there you can see the other clips. Now you need to be careful with this, especially if it's an old car like this one. This one's 2009. These are going to be fragile. The plastics like this do get brittle over time. Just press one in at a time, and you can see this is coming off. And then this will just pull out from the bottom. Okay, the next thing to do is these dials. These dials need to be taken off, the rings around the dials rather, and they are just clipped in. They do need to be taken off in a particular order. So if you look at the side, you can see that the tacho, for example, is over the speedo. So the tacho needs to come out first, and then you can take the others out. What I will do before I start is go and get a pair of gloves. Latex gloves or nitrile gloves are probably best to use. Or if you don't have those, just make sure that your hands are very clean. The oils in your skin. If you touch the diffuser at the back there, this area around here, or the dials, or any part of it really, the fingerprints will mark it, and it's very difficult to get those off. So I'm just going to get myself some gloves. To remove these silver rings, there are some clips underneath the rings. I think they're located, I think there's 4 of them on this big ring, and I think they're around about this location. If you just pull up the ring slightly, you'll feel where it's tight against. So there's be part of the ring that won't move at all, and other parts that does move. So the part that it doesn't move, where it feels solid, that's where the clip is. And what you need to do is just push the ring outwards slightly at the same time as pulling up, and you'll disengage that clip. You should hear a little click. Again, this is fragile, so you can move the needle out of the way if it's in the way. You need to just take a little bit of care. Oh, there's one. There's one here. Particularly stubborn, this one. Again, I'm taking it longer than it needs. I'm just taking my time because I don't want to overforce these. They will easily crack.
Some time later.
So this has been a real pain. This corner here, this clip, so there's 4 clips, 1, 2, 3, 4, holding this ring on. This corner will just not move at all. You might be able to see I've marked it up slightly, unfortunately. Trying to get that off. It's not too bad, but if I put any more force on that, I'm just running the risk of snapping this ring altogether. So I'm going to see if there's a way of getting in here without doing that. There are some clips around the side here that hold this top cowling on. So I'm going to remove that first, and then we'll see what's underneath. Put some card in the edge there just as I lever it up, just to stop these snapping back down. I can see now why everything needs to come off. So there's 4 screws, there's 2 here, and there's 2 just there, 1 there and 1 here. They are holding this plastic part onto the front of the printed circuit board. So basically this white part needs to be unscrewed, lifted off, and the circuit board is underneath. So in order to do that, obviously the needles need to come off because this lifts up and the needle is connected to the motor behind. So even if we take off the needles, the screws are hidden under this diffuser plate here. So the needles come off, the rings come off, the dials come off, and then the diffuser plate comes off. So with the shroud removed, it's given me more access to get under this silver ring, and I was able to use this tool here to press underneath and activate the clip inside, and eventually I was able to get it off. Now, the reason why I struggled so much, and this is going to help you guys out if you're doing this, is that the clips aren't all the same around this ring. So you can see there's only 3 tabs sticking out from the ring, and there isn't one on this side, which is here. The clips around this side here, sort of 1, 2, 3 position on the dial. The clip itself is on the outside of the ring, so it clips into the hole on this clip. So in order to get this clip off, this ring needs to be moved, pushed inwards slightly and then up to release it. This one is the opposite. The clip is on the inside and makes contact with the little dent there, little cutout on the inside of the ring. It actually looks, I'll put a picture up on the screen, but it actually looks as though it should just pull up without much resistance at all. But as you saw, it was hanging on. It didn't want to release. But when I got a tool in there and pushed the clip inwards, then it released. But yeah, so it's come out. There is a little bit of damage there, as I said, just when I was trying to get that out, but that's not too bad. At least it didn't break. So what we need to do now is hopefully get the other ones off. This ring here can come off now. The next ones on this side would be this one. This is slightly overlapping this one, and this one is slightly overlapping this one. So the order that these need to come off in is either this one or this one first, and then this one last. And of course this one can come off. So I'm hoping that the clips on here are not going to be this. Maybe this was just different because it was a larger ring. I'm expecting them all to be this type. So this means that the ring needs to be pushed inwards slightly and then released. So I'll just get my gloves back on. Okay, that one's released. It feels as though there's 3 clips on here, so possibly one here, and one here. So let's try the next one. Oh yeah, that's off. Okay, that's what they all should be like. This was this should be the easy part of this. So yeah, they're all the same type of clip. Let's try these ones. There's 4 clips on that one, but that came off really easy. So it's this one next. Just make sure that you be careful of the dial. Oh, that one's okay. And the last one. So these ones, the smaller ones, just pulled straight up. They didn't need to be moved around at all. So there's our dials removed at last. So the next thing to do here is to remove the needles. Now, looking at what people say, the needles is the trickiest part. So hopefully this won't cause any problems. Again, looking online, well, not just with GTR, with a lot of instrument clusters, the trick to this is to use some spoons. It's put them underneath and lever them upwards slightly. So I think I'm going to try and put something down on the dial here just so it doesn't damage it, and we'll try that. Just using some masking tape here, just to help protect that dial. Okay. That seemed to work okay. Let's make sure I've not damaged the dial. Feels like you're putting a lot of force on that. I don't know whether that is normal or not, but felt like quite a lot of force to do that. I think these dials just lift off, but let's try the needles first. You don't need to worry about the positions of these needles at this stage, because when we apply power to it, when you're testing this on the bench, you apply power, the needles automatically reset to 0. So when we're fitting these needles again, we just need to power cycle it, switch it off, and then we know that the needle needs to be on the 0 position. Oh, it's not a nice sound, that, when it cracks. Look okay though. one to go. The rest of these dials should just lift off. A bit sticky, that one. Yeah, it's just a little bit of sticky. So this this black ring there, and also there's one on the top of that one. It's come off with the dial. That's just looks like self-adhesive. This one feels the same. Yeah, again, just a little ring of self-adhesive just on there, just around the indicators. Okay, so with all that off, we should be able to lift the diffuser. Now this LCD here, this is the shift indicator. So this shows whether you're in drive or reverse, etc. I'm not sure whether that needs to come out first or whether we can lift this white part out next. Oh, there isn't actually 4 screws, there's 6 screws. So 1, 2, 3, 4, 5, 6. All those need to come out. I'll take those out next and we'll see how this display looks. So there doesn't seem to be an obvious way of doing this other than levering up the display, but it is glass, so you do need to be very careful. It is coming off. Just the only thing I can suggest is perhaps a small screwdriver like this. This is about a 4mm width screwdriver, and just take it easy. If anyone can suggest a better way of doing this, then please leave it in the comments. But, I'm sure it will help other people. This is coming off though. Bent one of the pins slightly there, I'll need to straighten that out. You can see the whole module is just glass, so yeah, it's not an easy way of doing that. And putting it back is going to be tricky as well. You need to make sure all those pins are aligned with the socket. We will deal with that when the time comes. So now, at last, we should be able to remove this shroud and reveal. There we are. Sorry, got the glare of the light there. So these ones around here, these in the white circles, there are backlight LEDs. The ones in the middle are the red ones that illuminate the needle. We also need to remove this message display. I wonder whether that's screwed in from the back. Yep, so 4 screws, 1, 2, 3, 4, and 1, 2 sockets plus this edge connector, they all need to be removed. So those 2 connectors just pull out. This one, this ribbon cable has 2 retaining clips at the side, so that needs to be pushed out like that, and then this should just come out. Not sure what's stopping that. Normally with these connectors you release these 2 pegs up and then the connector comes out. There we are. With those off, we can take the screws out. The message display. Now, this contains its own illumination LEDs. If you remember, the display's amber on this one, and it has the amber LEDs inside here. So I'm not sure yet whether I'm going to replace those ones with white ones. If this all goes according to plan, then I will possibly do these as well. So there's our board, right around. We've got 1, 2, 3, 4, 5, 6 white LEDs on the speedo. We've got 1, 2, 3, 4, 5, 6, 7 white LEDs on the tacho. And we've got 1, 2, 3, 4, 5, 6, 7 LEDs lighting up the shift indicator. 2 on the fuel gauge and 2 on the temperature gauge. So all of those we're going to remove and replace. So before I do that, I'm just going to test and see what type of LEDs these are. So I'm going to power it up and we'll see which contacts have power on. So our wires, yeah, they're still on the back there. So just connect this up to 12 volts. Right, that's connected up. Let's turn this light off and switch on. So we can see the problem there. This one, which is the fuel gauge, is now not lit. So it was the temperature gauge before. This is the one I saw failing in the car, but now it's the fuel gauge. A good tip to finding out the polarity of LEDs, such as these, and finding out which pins are which, is to switch your meter to continuity. When it's on continuity, it does deliver a small amount of voltage through the probes, so enough to light most LEDs, unless they're very high power. So looking at the legend on these LEDs, I'm not sure if you can see that there. In fact, let me just move it a bit closer. So hopefully you can see that. And the legend on the LED there, you can see the diode. It's going from positive on the left to negative on the right. So anode on the left, cathode on the right. So if we use our probes, this is set to continuity. We've got positive voltage in the red lead and ground in the black lead. So let's try the top two. And we're getting continuity there, but no light. So I expect that those two pins are connected together. Let's try the bottom two. And the LED is lighting there. Not sure if you can see that on the camera. Maybe just. So LED is just barely lighting there. So if I try the one, keep the anode on this pin on the left. Try the one on the other one on the right, and it lights. And this top left, and it lights. So this is actually a common anode LED. The common anode is this pin here, bottom left, and all the others are cathode joined together. Let's just try one more, though. They will be all the same. Yep. Yep. And the same for other LEDs if you wanted to test it. So the red one, I assume that's common anode. Yep, there's the red light. There are a number of options when it comes to the LEDs on this board. So I've unsoldered one of them, this one here, just to see what the pads are actually connected to on the board. And it turns out that when we were looking at the LED before, we were seeing that that particular LED was a common anode, which was the bottom left-hand corner. Pin was the positive, or the anode, and the other three were all connected together, and that was the cathode. Now, when I've taken off the LED off this board and checked the connections on here, we actually see that the bottom left-hand corner is the anode, so that's a common anode. The two connections on the right-hand side are cathodes, and the top left-hand corner is actually a no connection. It's not connected to anything, so it's just a floating pad that's not connected anywhere. So with that in mind, we can use either the same LED that was on this board originally, which was common anode, and the 3 cathodes are all connected together. That will work on here, of course. We can also use PLCC4, which has 2 connections as the anode and 2 connections as the cathode. And we can actually even use a PLCC2. So the PLCC2 has 2 pins only. They're longer pins, 1 on each side. And if we use that on here and bridged these 2 connections, the no connection and the positive, and on the other side, the 2 cathodes, it's still going to work. So we can use any of those 3 types of LED. The only type that we can't use is a common cathode. Common cathode will have 1 pin as the cathode. In fact, it'll be the corner with the indicator. So that little diagonal line on the side of the LED, that indicates the cathode. So it doesn't matter whether it's common anode or common cathode, that mark will indicate the cathode. So on a common cathode LED, where there's normally just the 1 pin for a cathode, that will be denoted by that line on the LED. And of course, if we had that here, we wouldn't be able to orientate it in the correct way to work on here. So we either need PLCC2 or a PLCC4 common anode, but the pins on the common anode, as I say, that we can have dual pins or a single pin and 3 others. Yeah, it gives you a bit of flexibility on here. So if you were wondering which LEDs to buy for this, we can actually use any of those. There are 2 ways you can tackle the soldering of these LEDs depending on what equipment you've got. The first is traditional soldering iron, and you're going to want the thinnest, finest tip that you've got because they are very small. And you'll need some flux and of course some solder. So that is one way of doing it. The second way is a hot air gun. Now this is my preferred method for surface mount because it's much easier. You'll see that. The hot air gun that I've got is a real cheap and nasty hot air gun. It literally cost me about £20 delivered from eBay, and all it does is delivers hot air, and you can adjust the temperature of it, but that's all it does. So whether it's a cheap one or an expensive one doesn't really matter. And some solder paste is what you need. Now I've got some in a syringe here. I've not tried this one. And there's some in a tin here. And the solder paste includes a flux already. So basically it's what a solder paste is. It's very fine balls of solder which are held in this paste, and it includes the flux with it. The flux helps the solder stick to the metal that you're trying to solder. So this includes it already. But if you haven't got this, then you're going to need, I mean, this solder is fluxed. There's flux in the solder to help it solder, but it's always good to have some extra flux to put on there as well, just to make that connection good. The paste includes that flux already, and when you heat it up with the hot air gun, it will basically turn into liquid metal and solder whatever you're doing. But you can see that because I'm going to show you both methods. I'm going to use this for most of this project, but I will show you how to use it with an iron as well, just in case this is the method you're using. Now the LEDs that we're soldering are these ones. They are tiny, and these particular ones, as you've seen in the diagram, these have got 4 legs on them, so there's 4 to solder. So I'm going to switch to a different camera when we start doing this, just so you get a better look. I'm not doing it on my microscope bench, so it won't be a microscope image, but it will be a bit closer than what this one can do. Now, whichever method you're using, soldering iron or hot air, you are going to want to clean the pads up first. So this is our board, and as you've seen already, I've already removed one from here. I guess you are familiar with soldering, so we're going to need some isopropyl alcohol and some flux just to clean this area off first. So again, you can use the soldering iron to remove these LEDs by heating up one side, lifting it slightly, heat up the other side, and the LED will come off. And then you'll want to clean up the area with some flux. So put some flux down, heat it up again, and then best way I find is some desolder braid, which is this stuff, and then we can just run that over the pads and clean it up. And once it's in this position here where you've got some nice clean pads, then we can solder our new LED to it. So let's get started with that. What I'll do first, I will remove one of the ones that's on here. I'm not going to show you the whole lot, but we'll do one or two. I'll show you removal of one, clean up the pads, and then we'll solder on using one method, and then we'll take another one off, clean it up, and we'll solder on using the other method, just so you can see how it's done. So the way I do this, and everyone's got a different method for soldering. Using the soldering iron, this is for me the more difficult method. The hot air is definitely the easier method. So what I like to do first is lay down a little bit of fresh solder just on these contacts. That, and as you've got the solder melted on one side, just come in and just ever so slightly lift that LED up. Like that. Now you don't need to worry about putting too much heat on these LEDs or damaging them, because these are the ones you're taking off, so we're not really bothered about those. When we come to put the new ones on, then we need to take a little bit of care about how much time we've got the iron on these, because if they're left on the heat too long, you do damage the LEDs. So now I'm just coming in with some tweezers, and again I'm going to heat up the solder on the other side. And there we are. So what we want to do now is we want to clean this up. So first of all, I'm going to put some flux down. Going to come in with some fresh solder. What I'm doing here, I'm just putting some more solder on, just so we can clean these pads up. Once we've done that, we can now desolder braid. Again, you might have a solder sucker or an air sucker that you can take this solder off with, but I don't have that. I just have the desolder braid, but I think it works quite well. We look at those pads now. They look pretty good. So what I'm going to do, I'm just going to go in with the isopropyl alcohol now. So it's on a cotton bud. And we just clean around that area. It'll all clean up. As like I said, this is just the flux from the solder that you're seeing. Okay, let me have another look at that pad now. Looks in good shape. So now we need to get our new LED. Surface mount LEDs typically come on big reels, so when you buy it, are going to arrive in something like this, which you need to take out of the packaging. Now the notch on this one depicts the cathode. So the notch is, let's focus up, the notch is actually there on this corner. So that's the cathode, and our cathode is on the right hand side. This is the cathode, this is the anode. So our notch on these particular ones that I'm using needs to go to the right hand side. Like that. So that's how it's going to sit. I'm putting these on with an iron. What I will tend to do is I'll just put a little bit of solder on this pad first of all. Just on the first one, like that. Then move the LED in. And then what we're going to do is just melt the solder, and as the solder melts, we're going to bring in the LED. Not quite over far enough, just need to move it over a little bit further. Okay, so that one's in place. We can solder the other legs. I'm going to put a bit of flux on as well. Like I said, the flux helps the solder to flow. So on the other side too. That one soldered leg, that temporary one, will just keep the others in place while we solder. To be honest, the tip on this is a little bit big for this. Okay, we'll go back to our first one again. Retouch that. Now, when that's done, we can just go back in with the isopropyl alcohol and clean that off. Just around here, clean up that flux. And that's that one soldered in place. Like I said, the soldering iron, it is the more difficult way of doing this. So I will show you the other method. Just before we do that, we can test this LED in place. As we saw before, we can use our multimeter in continuity mode. And there's our multimeter, so continuity. We put on the LED legs, you can see that lighting up there. So that's one in place, not too difficult, but there is an easier method. So let me put these lights back on and I'll show you that. So we'll go for this one. And I'm going to set this hot air gun for, I'll set it for 220 to start with. We may increase it depending on what the solder's been used on these components. It depends on what temperature you need to melt it. I'm just going to heat around the LED. Get ready with our tweezers. Like I say, if it doesn't melt in the first few seconds, we'll turn that temperature up. So I'll turn this up to 300. You're best starting off with a lower temperature and then work your way up. That way you reduce the risk of damage to other components. It's not too bad on this board because there's a large space around each of the LEDs, so you're not right on top of other components. If it doesn't melt at 300, we'll just turn it up a little bit more. There we are. You can still hear it because it's on a cool down, the hot air gun. But there's our, let's try and capture that. So I'm just going to clean these up with some isopropyl alcohol. I'm still going to use flux and solder and desolder braid. Even though these look quite clean, I am going to go over them with some fresh solder and remove it just before I put the paste down. Probably doesn't need this step, but I just like to do it. I just like to make sure these pads are nice and clean. Haven't got any old solder still on them. Okay, so with our solder paste, we need to get something to deliver it to the board. Let me get a little screwdriver. See if I can angle that light, just make it a bit better. There we are. So the way I'm just going to do this is to take a little bit of paste out of the jar. I've just got a little screwdriver there. And we're just going to place a little bit on each pad there. Just like that. On the other side. Doesn't matter if these pads end up sticking together on each side. They probably won't, but if they do, we'd normally sort that out. So if this was an IC, for instance, and you had two legs that were stuck together on one side, solder melts, they've melted together, you'd need to perhaps come in there with the desolder braid and take a bit off and sort that out. If this happens here, we end up with two legs on one side soldered together, it doesn't matter because they're all they're common on these LEDs anyway. So with that done, let's grab another LED. Make sure the notch is on the right hand side. We literally just need to put it into place over those pads. Just like that. And then all we need to do is just hit it with the hot air again. Now this solder paste is, when you buy a solder paste, it's got the temperature written on it. This one is 183 degrees. So that means it melts at 183. Put my other light back on. I'm running without that light, sorry about that. And I'll put the hot air gun on. And you should just see it suddenly turn to the solder colour that you're used to as this gets hot enough. There we are. And that is perfectly soldered on there. All four legs. Better, looks a lot better than this is the one we did with the iron. And this is the one we did with the hot air gun. Much easier. So let's come back in with the multimeter, just test that LED. I like to test these along as we go. Oops. So, yeah. So what I'm going to do, whilst this is in this position now, we've got two LEDs soldered in. I'm just going to test this on the power supply and see what these look like. We'll be able to compare them with the other ones. It might not be a true indication because when you have different LEDs of different forward voltages, then they can affect each other. It depends how these are wired up on the board, whether they're in series or parallel. But let's hook the power up and let's see what they look like. To be honest, I'm not happy with the color temperature of these LEDs. They are brighter, but they are too warm a colour for me. So these are the ones that I've replaced that you just saw me do. These are the originals. So yeah, they are brighter, but they're quite yellowy. Even though they're described as cool white, they're not as cool as these ones. And I do want it to be a whiter, bluier colour, rather than this warm white. So that's a shame, but I'm glad I found out now. So what I'm going to do, I will get some more LEDs and then we will redo this. The new LEDs have arrived. Here they are. These are actually PLCC2 LEDs, so these are the ones that have the larger connector on each side, but there's only two connectors. But as I've already shown you, they are going to work fine with this circuit, so there's no problem there. These are the same footprint, same size as the previous ones we were looking at. They just have the two connections rather than the four. Anode on one side, cathode on the other, of course. And I've gone for colour temperature a lot higher than the other ones. So I wasn't exactly sure what the other ones were, but they were described as cool white. And cool white To me, cool white should be around 6,000, 5,000, 6,000 on the Kelvin scale. And they clearly weren't on there. Whether they were, and it was just because they were next to the other ones, which were particularly bluish, they looked perhaps a bit warmer than they were. But yeah, I didn't like those other ones. So I've ordered these, which are described as 10K on the Kelvin colour scale and 12K. So these should be, according to the chart, these should be, well, bluish really on the chart. Now the ones that we had on the board before, you saw they were a bluish colour anyway. So all I can do is try these, and when I find one that I like, I'm going to pick on that, and we'll use those. So I'm going to put one of each onto the circuit, and then we can compare them all together. And if I find one that I like there, then they're the ones I'm going to use. So let me get these put onto the board for you now, and we can take a look. So let's put some power to this and see what these LEDs look like. These are the two that I've replaced here. It's flickering there because the display is dimmed. So if we use our two connections just to put it to full brightness, that will stop it flickering. So they look a lot better. The other ones actually look a bit purpley compared to these ones. They're obviously brighter, but you can see that the colour of those is it is bluish, but I think that is better. I do like that. I can't see any difference between those two. This one is possibly not quite as bright as this one. This is the 10K, this is the 12. I think they look almost exactly the same. I can't see any difference there. But I'm happy with the colour. It is a very bluish white. I think that's going to look good. I think my camera is probably altering the colour on this slightly because it's these ones are very purpley on the camera, but it's not like that. My connections at the back there. It's not like that when I'm looking at it. So these ones look slightly purpley, but these ones are not quite as blue as what you're seeing there. They're more white, which is what I want. So I think we're good. I think I'm going to use these. I'll probably go with the 10K, but I can't see any difference there. So what I'm going to do is I'm going to use the 10s, I'll replace all the others, and then we will come back. I've finished putting the LEDs on this board now. So all of the white illumination LEDs have all been replaced with those 10K ones that I've bought, the PLCC2s. And the solder paste and the hot air gun worked really well. It was really not much effort at all to put those on with that hot air gun. I'll just put the power on so you can take a look. There you can see they're all the same colour, of course, but it's a nice, cool, bluish, slightly bluish white light, which I think is going to look great. They're slightly brighter than the originals as well, so you probably won't need to have the illumination on your dash as bright as it'll go. You probably want to knock it down a little bit. If we increase that, that's maximum brightness there. But yeah, this went really well. So I think what I'll do is I will take apart the small display, so the message display that's on the bottom here, about this location on the dash. This is illuminated with its own separate internal LEDs. So I think what I'll do is I'll open that up and take a look and see how easy that'll be to replace the LEDs in that one as well, because I'd like them all to match. This is the message display. LCD screens there. Looking at this, I would think that the backlight is on this circuit here. See the circuit board would shine up into the display, but I haven't opened one of these before. I haven't seen any other videos online showing how to get into it. No screws visible. I'm expecting that it's just clipped together. You can see at the edge there, looks like a couple of clips. So I think we just need to work our way around and see if we can release these clips. You can see it starting to pop out the casing. Bit of tape here. I think this needs to come off. This is just holding this wire down. Okay, let's replace that later. So there's one clip remaining there. So the LCD display is on this part. We'll leave that as it is. And the backlight, you can see there's our LEDs along the bottom edge. 1, 2, 3, 4, 5, 6, 7, 8, 9 LEDs. And there's a diffuser by the look of it. There's a few bits to that diffuser. I'm not going to touch them with my hands. I'm going to get some gloves because I don't want to leave any marks on it. But you can see there's a diffusing sheet and then an acrylic plate. Put that to one side. And now we're left with this circuit board with our LEDs on. 2 more clips. Not sure how well you can see that. There's one there, one here, just holding that circuit board in place. So if we move that clip out of the way, should be able to Push that board out. Don't think there's anything else stopping it. This is how the LEDs are arranged in this circuit. They're in 3 groups of 3 LEDs. So 3 groups in parallel. There's also a resistor on here, 10 ohm resistor. Taking one of the LEDs off this board, and they are the same as they were on the dashboard. PLCC4, got the 4 pins there. But the difference here to the dashboard is that this pad is not a floating pad. So on the dashboard, this pad wasn't connected to anything at all. These 2 were cathode and this one was anode. A little mark there denotes the cathode side. Now on this board, these 3 pads unfortunately are all wired together within this circuit board in the traces. So it means that I can't put the PLCC2 LED on here, because if I did, it would join these 2 connectors here. This one is going to be connected to the cathode and this one is the anode. So it basically shorted out if I was to put the PLCC2 on here. So the PLCC2 is fine on the main dashboard circuit, but on this smaller circuit we're going to have to get PLCC4 LEDs. Otherwise this isn't going to work properly. So I need to get some more PLCC4 LEDs with the same colour temperature as the PLCC2s that I've already got, and then solder them onto here. So as I said, these are arranged in groups of 3. These 3 are in parallel, these 3 are in parallel, and these 3 are in parallel. So if we probe the anode of the first one, cathode of the last one, you can see those 3 light up. Just those 3. And again, if we do the middle, those 3 light up. So yeah, I'll get some PLCC4s ordered for this board. I'll go for the 10K colour temperature again so they'll match, and then we will come back and get those fitted to here. I've now got these replacement LEDs. These are the PLCC4 and they are the 10,000 colour temperature. The same size, same footprint as the PLCC2s, but these have, of course, 4 connections. You can see there. So we'll get these added onto the board and then we can test it out. can see the 3 new ones on the left there. Got the yellow gel because of the white LEDs. I think all of these white LEDs have blue chips in them, and with the yellow gel on top, that's what you use for the white LEDs. I think that's right. So let's give these a quick try. Oh, they are bright. Colour looks good. What I'll do, I will replace the others on the board and then connect it back up to the main circuit board and just see how they look. We can connect this board back up to the main board for testing without connecting the LCD. So the LCD had this flat flex ribbon cable here, and the power here, this power lead, is just the power to the LEDs. So fortunately we can just plug this in and test it easily. Plug that in there, and then this one to the bottom of the board. Okay, let's turn this light off. So this is on minimum brightness at the minute. The camera's a bit swamped out with these lights, but the colour temperature isn't too bad. It is slightly different. This is I'd say a bit more purpley if anything, and these ones are a bit more blue, but it's very close. Yeah, I don't mind that at all. And they are fine. I'd say they're the same brightness as these as well. So I think that's going to be just fine. So I'll put this back together, reassemble everything, and we will come back and I'll show you what it looks like. You can see that display there. It's more white now than it was before. So the amber display before, now with those LEDs, it's looking this sort of a light greyish white, which is what I expected. Let's just try and turn the brightness up a little bit. I'll cover those other ones up as well so you can see that display a bit better. That's looking really bright on the camera, that. So let's try and cover some of these up. Still swamping out, isn't it? I'll take a picture with my phone and put this up for you to look at. But yeah, it looks good. So what you want to do for the needles, putting these back on, is power cycle the cluster again, and on the power cycle the needles will reset back to the 0 position, and then all we need to do is line up this with the 0 and push it on. So let's reset that now. Okay, so they all should be at the 0 position. So just get over the top of it to line it up. And push them down. So that's this cluster finished. I think it's turned out really well. So I am pleased with that. The if you're worried about soldering those LEDs, then like I said, the hot air is definitely the way to go. And the results are fine. I mean, you saw I wasn't the neatest with the paste. It was a bit sloppy, but when the hot air gun heated it up, it just melted and everything went right. So the result was pretty good. We've come to the end of this video at last. It's been a long video. I did want to show you all the steps though required taking this apart and how to solder the LEDs, however you're doing it, putting it back together. I don't like watching videos where there's a step missing in a how-to video and you're left scratching your head thinking how is that done. So hopefully this has showed you everything you need to do this job, and I think it's turned out really well. The colour match at the end is very similar between the message display and the numbers themselves. So I think when we saw the bare LEDs and there was a little bit of a difference in colour, the filter on the LCD has actually made those colours very similar now. So I do like that. I was thinking originally of making this blue to match the shift indicator, but I think with this being incorporated in the dial itself, I think the match of the white numbers with the white display, I think this looks better. And then the shift indicator is obviously separate with the blue colour. So yeah, I personally think this is the best way to go. You of course might want to change the colour of the numbers or change the display, whatever you wish. Now what I'm going to do, just to help you guys out, I'm going to order a quantity of these LEDs that I've used, the ones that I've actually decided on in the end here, and put them up on eBay. I'll put the link down below, and then you can buy that kit of LEDs. I'll put them as 2 kits, one for the dials themselves and then one for the message display as well, because you might not want to change the message display. At least you know what you're going to get. You're going to get the ones that I've used here. Hope you've liked this video. If you have, please give it a like for me, and hopefully this has helped you out if you want to do this job yourself. If you've got any questions at all, let me know in the comments below and I will do my best to answer them. And good luck with your upgrades. I will see you on the next one.